It's 6:50. You're watching The Morning Show. Teaching lab specialist and REACT program director from U of I, Jesse Miller, is here. It's science time.
Yes, it's always science time for me.
Well, we are not as lucky as
I like when you bring these gloves because it means we're going to do something like messy or dangerous.
That's right. We're going to do both. That's
Good.
right. But not quite yet.
Oh, okay.
What we're going to talk about today is polymers. Right now, polymers are everywhere. Right. I mean,
polymers want a cracker.
Plastics. Some people call them plastics, but it's all polymer. Like, where's the laugh track? Anyway,
you're supposed to supply it.
So, what is a polymer? Okay, that might be the first question to ask. What is a polymer? Well, the word polymer means poly, meaning many, and mer, meaning, well, it's just a unit. Okay. So many units. So, whenever you have a polymer, what it is, it's a repeating unit in a chemical of a certain molecule. So, if polyethylene. Let's use that.
Right.
I have an ethylene. This paper clip represents like an ethylene molecule. Okay. Now, if I'm somehow able to hook two of these ethylene molecules and then three of these, and so on and so on, I would end up with a long chain, which we would call what?
A polymer chain?
Yes, polyethylene. Right? So this is basically all a polymer is these long chains of a certain type of molecule. Polystyrene would be styrene, which you make styrofoam from. There's thousands of different polymers that we make. Now, the one thing that's kind of interesting about these chains is that you'll hear like high density polyethylene, low density polyethylene if you look at your recycling codes. And all that means is like in a high density polyethylene, you have this chain that's a straight chain, and then it can fold in on itself and pack itself so it's really tight. Okay, so it's high density. But if your chain is to branch, then that chain can't really fold in on itself very well because the branch gets in the way, and so you get a lot of air pockets in there.
Do these happen in nature, or do you have?
Oh, sure. There's all sorts of biopolymers. You have polymers in your body. Your DNA backbone is a biopolymer.
So do you have special like polymakers?
Well, there are certain things.
How do you make them hook together?
We have what's called an activator. And it's a chemical that's catalyst for the most part that will initiate that reaction. There's different types of reactions. We have these, what we call a condensation reaction, where you mix the two things together. We're going to see one of those, and then it kind of crashes out. But there's others that it just kind of builds onto it. And it'll keep going until it's stopped by...
What's it stopped by?
Various things. Sometimes it's just kinetics. Sometimes there's an actual chemical that, if it gets on the end of it, it can't connect to anything anymore.
Got it.
So I mean, it's like a train car or anything else.
So what happens if it goes unchecked? Could it?
We're going to run out of molecules eventually, right?
Oh, okay.
It's not like...
Take over the world?
Yeah, it's not like the blob, right?
That's what I was worried
But the
about.
blob is kind of a polymer because he would just keep, taking this stuff. So anyway, that's the basics of a polymer. And like I said, all it is just many of these units that are connected together. And then they generally have certain types of properties. Some are rigid, some are more malleable.
And then coming up, you're going to show us kind of the polymers in action, right?
That's right. We're going to make some nylon.
Ooh.
Actually, one of the first.
I need a new pair.
Really.
Stick your leg in it.
Like you said, how's your knitting? Because we can make some fibers.
A little rusty, but
But yeah, nylon was one of the first, most important ones that came along, and then others came along. We're going to make some nylon, and then the 7 o'clock hour, we're going to make some slime.
All right,
Very
stick around. Nylon next on The Morning Show.